I was in the classroom, something I would always seem to lose would be my pens. They would always go disappear. Pens would always disappear in the classroom. In distance learning, the thing that always disappears are my little notes that I take. I have little notes that sometimes get scattered on my desk and they get lost. So I need to figure out a way to stop that. Another thing that always gets lost for me is my lip gloss or chapstick. That one is a major one. And it's so horrible when it ends up in the washing machine and all your clothes are ruined. So yeah, those are the main things I always seem to lose. Let's see what you all think. All right. Ooh, these are good ones. Oh, these are funny. My feelings, my keys. Oh, yes, I know. Socks. That one's good. Forgot about the socks. Glasses for glasses wearers. Yep. Earrings or socks. Oh, I agree. Earrings. Oh, I forgot about that. Losing the keys. Phone. Yeah, phone is a rarity for me, but I could see how that is. Yep, those glasses. They show up at random spots. Ooh, the wallet. That one would suck to lose. We got books and notebooks. Losing the headphones. Ooh, that's a good one. Yeah. Hair ties. Yep. They just mysteriously go somewhere. All those hair ties. Ooh, phone case. That means you probably take off your phone case. Ah, you always seem to lose your mind. I love how we're not talking like this is a very open question. It could be anything. Got phone, we got AirPods. Oh, those AirPods, the expensive ones, that would suck to lose. And we got a bunch of you who agree with the phone getting lost. Wow. Oh, charger. I love that one. Yeah. I think that also gets displaced because people sometimes borrow the charger. So then that's another reason too. Ooh, we displace good ideas. That is so true. You got to write those things down on a paper that you won't lose to get those saved for sure. All right, go ahead and continue checking in if you haven't yet. I am just making sure that I am checking in everyone here that's actually here. So let's see. And then I'll need some help, of course. Um, I always take my time with attendance. I want to make sure that I'm super careful. All right, y'all. So this is who I'm missing. Correct me if I'm wrong. So I'm missing Ariana. And if you're actually here, please. Sorry about that. I'm missing Dennis. I am missing um, Janet. Am I missing? I'm also missing Alicia. Is that correct? Alicia, if you're here, let us know. And I'm also missing Marco. And that's it. All right. So cool. So that's who I'm missing. Let me go ahead and repeat it so y'all can reach out to your friends. Um, oh no, we got Ariana, everyone. Yay. All right. So this is who we're missing, everyone. I'm missing Dennis, Janet, Alicia, and Marco. That's who I'm missing. Please outreach to our friends here who are not here today. Definitely want them into our pre-calculus first day back. Thanks to everyone for sharing on that check-in question. That was super fun. At least we're not alone when it comes to losing things. All right, I hope y'all got your coffee ready or whatever it is, your choice of comfort drink or whatever, breakfast that you got going to like get you set up here this morning. But let's go ahead and talk about our agenda and what we're doing today. So I'm going to actually wrap up my math story experience. So in the last module, I kind of talked a little bit of a part of my math story experience. I'm going to wrap that up today. And that's going to lead us into tips and advice for success. And that's going to be on a Padlet for participation. Nextly, we're going to be starting up this new unit with trigonometry. As a reminder, the notes are not on a binder paper, right? The notes are you go to Google Classroom, make a copy of the slides, and you just annotate the slides. And during this process, we're going to be going on the Padlet, pausing and checking in. So just keep that Padlet open once I give you the link. And we'll have our usual exit question. And I already posted the next asynchronous assignment. So we're not starting with asynchronous one because we're still kind of continuing, I believe, with the quarter. So I'm not exactly sure on that, but I'm just naming the next, our first asynchronous that's due this module, asynchronous number 7. Um, yeah, so I'm not sure yet about, so we're just continuing it. So it's gonna be async number 7 that's gonna be due on Tuesday. Does anyone have any questions about our agenda or anything like that? Let me know. All right, everyone. Awesome. I think we're good. All right. Let me go ahead and let's continue talking about my let me continue talking about my math story experience. So as a reminder, everyone, I was a teen that was very lost, didn't know what to do with anything in my life. I turned to math because I had a teacher who just did like step by step. I liked how clean it was, how there was an answer to it, when everything in my life just did not have any answers. So I really just grew to love the math process, and I grew to love memorizing steps. Once I got into college, that's when my kind of I hit a bit of a depression because I realized I actually wasn't what you would say is good at math. I actually was just good at memorizing stuff, and it's kind of like my high school a little bit set me up for that. So I had some depression. I scored very low on a first exam over at UC Berkeley, and after that, there was a point in time when I hit back into the books. I had to teach myself how to study and kind of just figure this all out from starting from ground zero, like what is math and how you actually learn it. So a lot of you in the last module actually asked a question that I didn't get to answer. I didn't have time to answer when I shared my math story. Some of you said, well, what happened? How did you actually get out of that depression? And why did you even go into teaching math? So those are all valid questions, and I want to make sure I answer those and with some advice and tips. And then you all are going to think about some advice and tips. Okay, everyone. So, what did I do when I was depressed up in UC Berkeley? Because I got a very low score in math and I was very lost. What I did is I went to the TA. So at UC Berkeley, you actually are less likely to meet with your professor. You actually meet with TAs. They're like the helpers of the teacher. They have like, sometimes they can have as many as 10 TAs, and you're just assigned to one of them and you just go to their office hours and they're there to help you. So I went to the TA. I went to the TA and I kind of told him what happened in class. I said the teacher like put up a problem on the board, and I remember he asked the class a question and everyone in class answered in unison. Like, "Oh, the answer is blah." And I was just sitting there like so confused, like how do they, like where do they get? I don't even understand what's on the board. And so I went to the TA and I told him I was like, these people answer so quickly and I don't really understand what's on there. So I feel like, what am I doing? And one thing he said that really clicked was, it doesn't matter what other people are doing. It matters what you understand. It matters that you understand the concepts, no matter how long you take. So for me, that really stuck with me because I realized at that point that I wasn't focused on myself. I was kind of focused outwardly and thinking about others and comparing myself. So that's when I kind of had like a little click there, like, oh, if I want to actually get better at something, I need to focus on myself. So here's a piece of advice that helped me. I went to a helpful resource. I went to office hours. Colleges have this, we have them now here. So go to a helpful resource. And next thing, my mindset again was not focused on my growth and my learning. I had to readjust my thinking and change how I'm looking at things. So another way you could think of that is I had to interrupt those negative thoughts that I'm not good enough and all of that with positive ones. The positive thought I interrupted it was, hey, it doesn't matter how long I take to understand it, as long as I'm trying to work to understand it. And it doesn't matter how long it takes, just like that TA told me. Another thing is I had to understand what I was doing and why. So my next tip here was, what ended up happening is I needed to make sure I spent actually time studying. What that meant for me was independent sense making. So I had to just understand, like, wait, why is this? Why are we doing this step? Why? Okay, I had to study it. I had to go into books and actually take time to actually study, take hours basically in college to actually sense make. And another important key fact was I had to join study groups and study with them. Let me tell you all, it's super easy to actually join a study group in college. I had a bunch of social anxiety in college, and it was like so hard to talk to people. But even me, who struggled with that, I was able to join a study group, and we were able to kind of like understand together when we were all stuck. And I felt I met like-minded people that were stuck like me, so it didn't feel so scary. And I had to remember my motivations. So one of my motivations for even trying to major in mathematics was because I didn't really have role models that looked like me in school, in high school. So I wanted to be, first off, female mathematician. I'm a female, and also I'm Latina, and I wanted to have that representation. So what that meant for me, and that can mean for everyone else, is setting and reaffirming your goals. Like, just remember like why you're there was something that also helped me get through that depression phase. So in the red here on our slide, on this slide here, here are my advice and tips. This is what I did. I went to office hours. I went to a helpful resource. I had to interrupt negative thoughts with positive ones. I had to put in some work. I had to independently sense make and join some study groups, because again, remember y'all, with collaboration, that's when deep learning actually does happen. I had to learn that in college. And lastly, I had to have a goal. I had to set and reaffirm what were my goals. Why am I doing this and why does this matter? So that is what I did to get out of that hump when I was in college. So that's going to transition us into the next activity, y'all. So again, I hope you've already opened up your own copy of the slides, because the link to the Padlet is on there. If you did not, I will put the link just so that we don't hold each other back. Okay. I gave you some advice and tips based on my own experience. Of course, everyone has unique individual experiences, right? So here's my question for you, and that's going to go into the Padlet. Do not forget to put your name or initial. But here's a question that you could think about. We're going to have about a minute or two. What advice or tips would be helpful to you or someone else when they're struggling with a concept or a mindset that they have? This is going to be our first participation point today, everyone. And we are period 1. So if you're on our slides, I see a few of us there. You're going to click on the first Padlet. Don't click on period 3. That's how I'm going to be tracking our credit. Let me also put this in the chat so that we all have access. And let me know that you're able to write on it too. You should be. Okay. And again, for those who are joining my slides, we're on slide number 6. Let me go ahead and click it and open it with you, everyone, as well, so you can see what's up. So when you go onto the Padlet, perfect. All right, y'all already know what to do right here. We got 3 people on it already. We're gonna be on the first column here on the Padlet, and we are just putting what advice or tips would be helpful to you, like what's helpful to you, or someone else when they're struggling with either a concept in any classes or a mindset that they might be struggling with. Let's go ahead and put down some stuff and take a minute. I'm gonna put the directions back in the chat. Let's take a minute and come back. For those who are done, just take some time and take a look what other advices everyone is giving. It's a great way to kind of just set ourselves up to prepare for this, new unit. It's very beautiful. I think it'll take me forever to just read everyone's beautiful advice. So once you're done, go ahead and scroll through and just take a look at these advice that is going to really be helpful to us all. All right, everyone, welcome back. Oh my goodness, this thread is very beautiful. Almost is moving me to tears, to be honest. Um, y'all are very a very sweet group. Thank you so much for sharing all your advice and tips. Again, just that one thing that TA guy said at my at UC Berkeley, that one thing just it clicked. So just one advice could help someone out. So it's and even yourself out. So it's very, very impactful. So thank you so much everyone for sharing. Y'all are the best. We're gonna go ahead and transition into our unit, everyone. So as a reminder, go to Google Classroom, make a copy of the slides and follow along if you haven't yet. So again, make a copy so you can actually annotate and stuff. We're gonna start with an introduction on trigonometry. And how we're going to start this off is actually talking about trigonometry in the real world first. I kind of want to first talk about why this is useful, and then we're going to dig into the dig into the math of it. So our learning target is I can explain what trigonometry is and how it shows up in the real world. Hopefully by the end of this lesson, let's just keep that learning target in mind. I'm going to pause at this slide for a bit so y'all can read it, process it, all of that. All right, y'all. So let's go on. So trigonometry in the real world. So first off, let's talk about how this first shows up. Waves and trigonometry. So some of you have seen waves in your physics class already. Sound waves, water waves, color waves, the color wavelength. There's so many different ways that waves show up in the real world. I'm going to talk about a few, but there's way more. Okay, so many things in the world today can be modeled with trig functions, trigonometric functions. I just say trig. Every repetitive vibration around us, for example, has some type of graph showing the movement of airwaves it creates. And this one that I'm talking about here is like music notes or sound. When you hear any sound through your ear, it's basically transmitted through waves. So take a look at this picture, everyone. So when you hear sound, it's basically air molecules getting vibrated with each other. So as you see, the air molecules are very close together. That corresponds to the wavelength being high, like a peak, and then it goes low, and the air particles are not close together, and then it gets high and so forth. You can see this visual better. And how the waves are modeled in the real world is with a trig function. So let me just circle this here. This right here is a sine function. It looks like a wave when it's graphed. Sine is a trig function. It comes from trigonometry. It comes from when y'all were studying those relationships in geometry before, just to kind of remind you of where a sine function comes from. Yes, wave check. Thank you, Jorge. So that's one way, right? There's actually many other ways. Let me talk of another one. So not only sound, right? Waves also show up in, let's see, waves can also model repetitive motion of some object. So I think maybe you've seen this in physics. So like a pendulum, that thing that swings like this, or a slinky. You all know what a slinky is. Hopefully you played with it as a child, your childhood, hopefully. There are many more situations, of course, that can be modeled with trig. You could just Google it right now, but if you Google it, you'll find even more things. But here's like modeling the motion of an object, and it's a repetitive motion. Swing side to side, slinky goes up and down. Repetitive motion can be modeled with a trig function. Now, this is a very technical trig function. It has other aspects to it, like this W and these pi symbols, right? But after all, if you break everything down, this is modeled by, and specifically it's a cosine function. Cosine is also a trig function, just like sine is. So in this particular example, you can model the behavior of the pendulum or the spring, its motion, with a cosine function. And again, we're gonna learn later on in this unit how to actually do that, right? But this is just a little introduction to show you why waves are important. Okay, so now let's do a Padlet check. Before I go ahead and start telling you all what is trigonometry, we're gonna go on column number 2 on our Padlet, and I want you to remember to think about what you remember about trig. So probably in 10th grade, when you were in geometry, what do you remember about trigonometry? So we're gonna go back in the Padlet, everyone, on column number 2. Let me also, again, once more, post this in the chat. But again, you should be on our slide. We're slide number 11, and we can begin. Yes, I see a lot of us already on here. This is exciting. This is great. I'm going to again put the directions in the chat. We'll come back in about a minute. All right, everyone, welcome back. Welcome back. Wow, I see a lot of commonalities in what y'all posted. A lot of you are remembering SOHCAHTOA, that thing that kind of helps you memorize these trig functions. I love how I love how Francisco right here you wrote down all the words and vocabulary you know here for like sine, tangent, cosine, hypotenuse, adjacent, opposite. Very great. We got SOHCAHTOA coming up a lot of times. I was laughing that someone yeah, someone memorizes it with suck a toe. I love that. I love that we're mentioning sides and angles. Um, ooh, we got some definitions here. Sine being opposite over hypotenuse. Cosine being adjacent over hypotenuse. Tangent is adjacent over opposite. Hello, I think it was triangles. I think you're good, Miles. Yep, we got some hypotenuse, opposite, adjacent. A lot of you remember those. That's great. Very enduring understandings y'all had there. We've got SOHCAHTOA. Let's see if there's anything different. I see SOHCAHTOA. I see the trig functions. Ooh, a new one is one popular trigonometric formula is the Pythagorean theorem. Yes. And then we have a few who forgot, right? That's okay. Just take a look at what everyone else is writing. Maybe something's gonna pop up there. If you don't, that's fine. Just read it. Ooh, you can use it for estimating building heights. Some of you remember its application. I think that's awesome. Oh, okay. So nothing new to add down here. Definitely. Yeah. Yeah, she is amazing, Miss Lauren. Of course. Yes. All right, y'all. Thank you so much for sharing what y'all remember from trig. I know every year, everyone's pretty on top of their trig. Miss Lauren was awesome. Okay, awesome. Let's go ahead and go back to our slides now. Thank you so much for sharing what y'all remember, because yeah, that's going to lead us into what is trigonometry. So we're going to go into the definition. I am on slide number 12, everyone. Let me go ahead and hit present. Slide number 12 on our slides right here. Okay, let's get our definitions down. What is trigonometry? So trigonometry is a type of mathematics that studies the relationships between sides and angles of triangles. Trigonometry is found all throughout geometry, as every straight-sided shape may be broken up into a collection of triangles. So yes, a lot of you mentioned sides, angles. A lot of you mentioned a lot of geometry, like adjacent, hypotenuse, functions itself. All of you were correct. Who remembered something, you were correct. But let me show you an example. So what do I mean by every straight-sided shape can be broken up into a collection of triangles? Here's some examples of what I mean. So if you have like this many-sided figure, you could cut it up into triangles. And from that, you could kind of perhaps, I don't know, find the area or find the perimeter, right? You could just cut this up into triangles to make your life easier. Here's another example of how something like a square can be broken up into triangles. So that's what I mean when it says every straight-sided shape can be broken up into a collection of triangles. So kind of like it's everywhere. Triangles can represent a lot of things if you break it up like such. So that's just a little example there. And there's our definition of trigonometry. Let's look at further things that are trig. And I have below, you can see example of how trigonometry relates the sides of a right triangle. As a reminder, a right triangle is a 90-degree angle. You have seen this in geometry, and you've all mentioned this already in the Padlet. Boom. That stuff y'all were mentioning right here. Though you could see probably the ones in blue. Perhaps these are new. I have no idea to you all. I know sine, cosine, tangent. Some of you mentioned these, like opposite over hypotenuse, adjacent over hypotenuse, and there's your tangent, opposite over adjacent. Some of you have that ingrained in your mind. That's awesome. There's also the reciprocal identities. There's something called cosecant, secant, and cotangent. And all they are basically, for example, cosecant is simply the reciprocal of sine. See, it's just, it's instead of opposite over hypotenuse, it's hypotenuse over opposite. Secant is the reciprocal of cos, and cotangent is the reciprocal of tangent. So these are just the ones to know. And these for sure, they're in our slides. They're also going to be in your big ideas packet. So those are just definitions to know. And yeah, a lot of you mentioned already SOHCAHTOA. SOHCAHTOA helps you memorize the relationship of the sides of a right triangle, but only for sine, cosine, and tangent. It doesn't really help you with the reciprocal ones, the ones down there. But I do think that once you know your basic three, you're able to just simply flip the fraction to get the additional three. And then there was a thing, isn't that like negative cos or something like that? Oh, so some of you are kind of bringing up some past knowledge. So I think I know what you're saying. Like you're saying the inverse of cosine. It looks something like cos inverse like this. Let me write it down. And y'all use tables, I believe. Yeah, like in Miss Lauren's class, y'all use tables. and you were able to find like a missing angle or something, that is actually different. So this is different from the reciprocal identities, but that is an amazing thing to bring up though. Yeah, that's amazing that you remember that. Woot woot. Awesome. And see, isn't this great? So I'm showing you like what like another example of what trigonometry is. What's great is that many of you already kind of mentioned this and knew that. So this is prior knowledge to many of you. And if it's not prior knowledge, well, here it is. You have access to it right here. You have these notes right here. You have these definitions that you could use. Let's move on to the next one. Example 3, let us actually review how to do SOHCAHTOA. Let's just do some basic review on this. Of course, this is pre-calculus. We're not going to focus on right triangle trig, but this is just to kind of get us back in those motions of trigonometry. So our goal for this example 3 is we're going to find sine of A, so the angle A, tangent of A, and then lastly, we're going to find sine of C. So I'm going to kind of describe my process of doing it. If you remember a different way, feel free to share with us. Okay, so step 1. Because I know I'm going to be doing sine of A and tangent A first, right here, what I do is I kind of focus or circle the angle. So because it's A, I'm going to circle A. Next thing that you do, or that I do, I label the sides. So the side opposite of A is going to be opposite. This long side, the longest side is going to be your hypotenuse. The remaining side is adjacent. Let me go ahead and show you what I mean. I actually wrote this in the slide. Oh, okay, so I guess I started with labeling my hypotenuse first. You could think of the hypotenuse as it's always opposite of your right angle, and or it's the longest side. Hypotenuse. Then I did the opposite of A, the side opposite of the angle A, right here. That's going to be O, opposite. And then my remaining side, I just think of that as the adjacent, whatever's remaining. So that's step 2, you label your sides. Step 3, you go ahead and just apply the definitions. So sine, according to SOHCAHTOA, or SOHCAHTOA, for some of you that helps, sine is going to be opposite over hypotenuse. So I already have my sides labeled. So sine is going to be 40 over 50. And then you could reduce 40 over 50 into 4 over 5. You just cancel out the 10 top and bottom, and that's why we get 4 over 5. That is sine of A, sine of angle A. Again, please make sure you write down any questions. Right after this, right, you're going to have a Padlet. So right after I do 2 more examples, you're going to go onto the Padlet and try one on, try this on your own, try to apply it to the best that you can. Okay, next one we're going to do is tangent of A. Well, this is great because I've already labeled my sides for angle A. All I have to do is look at what tangent is. So if I go back to SOHCAHTOA, tangent is O over A, and thus it's going to be 40 over 30. So then I just go right here on my slide, 40 over 30, that reduces to 4 over 3. I have no idea why this 4 over 3 doesn't look the same. I don't know why, but 4 over 3 is the answer for tangent of A. So again, once again, this is a little bit of review. Your Khan Academy practice, you're going to be just reviewing this. And this is review from geometry, just to kind of, again, get us into the motion of trig. Get us used to seeing sine, tangent, cosine, because we're going to be investigating these functions later on as waves. All right. Okay, so now this last one is interesting. Sine of C. I noticed that my angle is different, so that means my focus isn't going to be A anymore. I can't just focus on A anymore. What that means is I have to focus on, let me just take these away. I have to focus on now C. If that's the case, I need to relabel my sides. So notice how everything went away. So originally it was, I labeled it, but now because my new focus is C, I have to relabel my sides. So This right here, the longest side is always going to be hypotenuse. The thing that changes though, when I change my angle, is going to be the opposite side. The side opposite is now 30, and the remaining side down here is going to be adjacent. Let me see if I did that in my slide. Hold on. No, I did not. So I'm going to write it in. Sorry, guys. So for this one, when we change our angle of focus, this is going to now be opposite. This is always hypotenuse. This doesn't change. And the remaining one is now adjacent. Because we're doing sine, we're going to do opposite over hypotenuse. So that's why we should do 30 over 50. And then when you reduce that, you get 3 over 5. Notice how it matters your angle that you're focusing on. Sine of A was 4 over 5, but if you change your angle, like sine of C, you get 3 over 5. Again, we're going to have some Khan Academy practice. For some of you, right, I seen some of the advice you gave. Some of you, the Khan Academy didn't work, right? But you did list some ideas that did work. Some of you outreach to your friends. And then some of you did mention that, hey, the Khan Academy really did help. So again, look back at those tips for what helps you review this. They were amazing tips. Okay, so we went over this. We're gonna now go into the palette and try it out on our own for a bit. So for those who are ready, it's right there, Padlet period 1. And again, I put your asynchronous assignment will help you kind of refresh this practice just to get you back into the tone of trig. I'm going to put the link into the chat for the palette once more, and we're going to try this out. We are going to be on column number 3. So here's our you try, everyone. You have a triangle. It's already labeled for you. And your goal is to find the cosine of C. Go ahead and put what your answer, what you think it would be. Maybe some of you, if you could write Y would be cool. That way anyone else who's struggling with this can kind of see why. That would also help us as well. I'm going to put the directions back in the chat, and then we'll come back in about a minute-ish. All right, everyone, welcome back. I do notice that a few of you are probably still writing. I did notice that initially a lot of you had 16 over 20. And then I did see that there were different answers, but then I did see an adjustment of answers. So let's go ahead and try and see first off, instead of me just talking, but for those of you, because I see the common recurrent answer of 16 over 20, or I see 4 over 5. For those, or for someone who got 16 over 20 or 4 over 5, are we able to explain what you did and how you got that? If you want to unmute or use the chat. So I just want to first open up that opportunity. If anyone knows, how do we get that? All right, so I see Francisco in the chat. You said divided 16 over 20. Before you divided 16 over 20, like how did you even know to do 16 over 20? I saw someone initially put something like, oh, 12 over 20. I'm not sure. Like I definitely want to know, like, how do we know it's not the other ones? So we have some feedback there in the chat, everyone. So 16 is adjacent and 20 is hypotenuse. And then Francisco, you agree. That was from Aisha. And Francisco, you said, because 16 is the adjacent and 20 is hypotenuse. So you both are saying that. And then, oh, okay, I love this. So Rahelia is giving us some labels to put. So let me do that. That way we can help some students who initially didn't have that, right? So we have H is 20, great. And again, remember y'all, H is your longest side. We have that A is 16, adjacent to 16. And again, if we're looking at C, right, because we're being asked to find the cosine of C. And then after that, okay, cool. So y'all showed me that we have an adjacent, we have a hypotenuse. And then what do we do from there? I see that's how 16 and 20 are coming from, but how do we know what to put over what? Let's see if there is anything else there. There, okay. Thank you, Francisco. So co. So from SOHCAHTOA, the co, which tells us we have to do opposite over hypotenuse. No, wrong. Okay, what do we adjust it? It's okay, no problem. I'm totally going off what you all are saying. You guys are filled with golden knowledge. Go ahead. If it's wrong, how do we adjust this formula? Ka. Got you. So ka toa. Love it. There we go. A. So we got, it should be adjacent over hypotenuse. So adjacent over hypotenuse. That's how we got 16 over 20. And if you are to reduce that, we get 4 over 5. Oh, that's okay. And there's just a typo with the O. No problem. Oh, that's a good question. So there's a question of, I wonder what would be the opposite for point B. Luckily, you won't ever be asked to find a sine, cosine, and tangent for this. That's an interesting question. The opposite, if we were to say angle B, would actually be equivalent to the hypotenuse. That's a freaky, yeah, it would be a freaky thing, but that's a good thing to investigate. Yeah, it would be the same as the hypotenuse, but you're not usually asked to find sine, cosine, tangent of a 90-degree angle, but we will talk about it a bit later on. That's a great wonder. Okay, y'all, thank you so much. And thank you for those who were showing us how you got this answer. I appreciate it so much. All right, let's go ahead and get back into our slides. We are on slide number 16, everyone. Perfect. I think I timed this pretty good today. Yay. Okay, everyone, y'all ready? I am on slide number 16. Example 4, here's the new thing. I hope it's new. I don't know. Maybe it's not new. Actually, I don't hope for anything. It's good if it's new. It's good if it's not new. Okay, so here's the new thing that we're going to be learning. Below, let me go ahead and put it. Below, we see something called a unit circle. So this could be a new knowledge thing. What is a unit circle? A unit circle is a circle with radius of length 1. And you could build right triangles inside the unit circle. So this is interesting. This is a definition. I see a triangle there. I see I see some things that you all mentioned about hypotenuse, adjacent, opposite. We got some new things in there. I see some new words. So in a second, go ahead and study this, y'all. But I'm just circling new words. Go ahead and study this. Because in a second we're gonna do some notice and wonders, right? I just introduced a new definition to y'all. Um, it's a unit circle is a circle with a radius of length 1, and it's something that you could build right triangles inside of. So think about that new definition. This is new. It looks like a pizza slice. Wow, yeah, it does. And now I'm thinking about that. The red is like pepperoni. Then we got maybe some jalapenos or some pepper. I don't know what the blue would be, but definitely you could think of that like a pizza slice. Now, what I'd like you to do, here's our new definition, right? I want you to first engage with this with a notice or wonder. And we're going to go back into, it's going to be our last, I think, last Padlet. Boom. Before I tell you what is a unit circle, I need you to first engage with that picture that I gave you, engage with the definition, and try to put down some notice and wonders. Oops. Let me go ahead and get the link back for those who need it. We are on the last column, everyone. Let's make sure you put your name or initial. Make sure you answer all columns there. It's going to be our first day credit back. Definitely. I see many of us getting beautiful amount of credit. So we are on number 4 on the Padlet. Or column 4 on the Padlet. Put down some notice or wonders of this unit circle. Go ahead and take about a minute, and then we're going to go ahead and come back, y'all. I am excited to see what y'all are noticing. What are you wondering about this new thing? All right, everyone, welcome back. Always blown away by the type of questions we're being asked. It's really great. I love that we're wondering, like, why do we need a unit circle exactly? And we're gonna get to learn why. Um, Perhaps, it could be connected to what we discussed in the beginning about real world connections. I wonder, right? A lot of you are wondering how is that terminal side related to hypotenuse. We wonder, there was a wondering as to how many triangles fit inside the unit circle, and I forgot what where that was. There we go. How many right triangles can fit? What does the initial and terminal mean? Oh yeah, a common one that also came up is what does the ref stand for? I think that came up like twice. Um, we're gonna also learn that too. So um, deeply later on. So I don't want to just start doing a telling you what everything is because it's not going to stick right now, right? If I were to tell you. So what I'd like you to do is to just hold on to your questions or maybe hold on to others questions. Please make sure you put your name or initial right for your credit. I did see one who didn't have name or initial. I definitely want to give you your credit, so please make sure you put your name or initial. I think, yeah, there was only like one anonymous that didn't put your name or initial. Please do so we could get some credit. Okay, let us come back, everyone. That was beautiful. Okay, great. Let us go ahead and jump into our checkout. Our checkout question is going to be answered in the chat. So I'd like you to think about, well, what is a question now that you just have in general about this new unit? It doesn't have to be related to the one you just asked about unit circle. What's a question you have about just in general this new unit? It could be about mini final. It could be about, I don't know, group work, so many different things you could ask about just generally. Great. I love this question. Is asynchronous number 7 due tomorrow or today? Tomorrow. And if it says today, I'll fix it. So it's due tomorrow. Thank you. Thank you. It's a good question. And thank you for those who also answered there in the chat. Yes. All right. What are some questions or anything you have about this new module? There's a question right there. Can you please go easy on us with the final? Wonder what easy means here. I definitely want to push your brains to work, that's for sure. But has like little to no work. Hmm. You don't want to experience what I did in high school. I had little to no work because I had to memorize stuff. And y'all having some college won't be that easy. All right. Any other questions? Those are great. Thank you for asking that. Thank you for even asking, like, hey, can you go easy? How challenging will the upcoming assignments be? Let's see. The challenge will be something that you can tackle. You can tackle the challenge. Like learning is never easy. If something's easy for you, it means you're not learning. For sure. Are we learning like the advanced version of trig? So yeah, we're not going to be learning like triangle trig, like geometry. We're going to extend that knowledge. And some of it has to do with that unit circle that we just saw. So that's a great question. Will there be more homework? So the homework is there to support you, such as like Khan Academy and stuff. And what I usually do 3 times per week. Homework is usually due 3 times per week. So Tuesday, Thursday, Sunday. So that those are the usual homeworks. And guess what? I always accept all your work. So turn it in and don't worry about if you need more time. Just let me know. I'm always very flexible with your learnings. These are great questions, y'all. Go ahead and put any last minute questions or any last minute thoughts. Y'all are amazing. Thank you so much for today. Oh my goodness, I tell you, this Padlet is gonna make me cry. Y'all are so supportive of each other. But yeah, so if there's no more questions, y'all have an amazing day. I'll see you. Bye, everyone. Bye. Enjoy. Enjoy the rest of your day. Bye, y'all.